Hello, hello. Hello over there. Good morning, good afternoon, good evening, my dear students. This is your one and only AG sir, and today we are here with again an LM series. Today we are going to discuss exercise 2 level 1. In that the topic is equilibrium questions. Okay, the question number 1 is on your screen. Question number 1 is, in the figure given below, okay, if all the surfaces are assumed to be smooth and force of 100 Newton, if acceleration of block B of mass 20 kg is A and tension in the string connecting block A and mass 20 kg is T. A of mass 20 kg, tension is T. Then just after, when the force is applied, tension is okay, so and so and so and so. First of all, surfaces are smooth, so this block 20 kg, 100 Newton, and no friction is over there, we can write F equals to ma. So acceleration will be force upon mass, that is 5. So acceleration is 5 and 5. Okay, what about tension? See, there is no net force acting on this in horizontal direction. There is no such force which pulls this block in this direction. So force is absent. That means definitely the tension, this is tension, this is T cos 30. T cos 30 will be 0, which means T will be 0. So there will be no tension. Tension is equals to 200 Newton. That is absolutely wrong. The tension will be 0 and acceleration will be 5. Next question is, oh, easy peasy. Sorry for that. A spherical mass of ball of mass 5 kg rests on a two planes which making angle 30 and 45 respectively with horizontal. The system is in equilibrium. The normal force is exerted on the ball by each of the planes. Planes are assumed to be smooth. MG Yengappa and 30 and 45 representing all the vectors in coordinate system. So we have mg, this is and 45 with angle 45, and we have this angle is 30 and 30. Okay. So resolving the components, and 30 cos 30 and 30 sin 30 and 45 cos 45 mg plus and 45 sin 45. Okay. So writing left equals to right and another is up equals to down. up equals to down means n30 cos 30 is equals to mg plus n45 sin 45. n30 cos 30 is equals to mg plus n45 sin 45, and left equals to right n30 sin 30 n45 cos 45. n30 sin 30 n45 cos 45. Here you can change by this as a cos and this by sin, because for 45 there is no such difference. Sin 45 and cos 45 are same. 45. So n30 sin 30 is 1 by 2 and 45 1 upon root 2. So we can write n30 is equals to root 2 and 45. So here we can write, in place of n30 we will write root 2 and 45 cos 30 is root 3 by 2 equals to mg plus n45 sin 45 is 1 upon root 2. Resolving the equations, not having much space. So let me solve it over here. n45 root 6 by 2 minus n45 1 upon root 2 equals to mg. The mass of the ball is 5 kg, so that is 50. Mg is 50. So n45 is common, 50 upon root 6 by 2 minus 1 upon root 2. So please solve this equation. You will get n45 and put the values of n45 over here. You will get n30 and you can compare it with your options. Okay, question is not difficult, so just solve this question. Okay, next question is, objects A and B, each of mass m, are connected by light extensible cord. They are constrained to move on a frictionless ring in a vertical plane as shown in figure. The objects are released from the rest in the position the cord will be. Okay, we don't know what is the tension in cord is, but let us resolve the components. This angle is 45. Why? Because this is R and this is R, so this is 45. So this is T sin 45, T sin 45, this is T cos 45, this is T cos 45. So here this will be T cos 45. Acceleration of this string is, this point B is A, and same way the acceleration of this point A will be A. So for point B, mg T sin 45 A, and for this is for point B, this is for point A, In this direction we will have t cos 45, and acceleration will be in this direction, which is a. So we will get the equation mg minus t sin 45 equals to ma, and the another equation will be t cos 45 equals to ma. T cos 45 equals to ma. So here we will have mg, t sin 45 and cos 45 will go, so 2 ma, and acceleration becomes g by 2. Okay, so from here we can get the tension, putting the value in this equation. So T is equals to m, a is g by 2 upon cos 45. Cos 45 will be 1 upon root 2, so answer will be mg upon root 2, that is our tension, mg upon root 2. So mg upon root 2 is our answer. Okay, next is this one is a easier question, not to worry. Two masses m and capital M are attached to a string as shown in figure. The system is in equilibrium. Then what is the angle? See, here you can see mg will act downward, so this will be T1, let me say, this will be T2, this must also be T2, because these two strings are making the same angle, means the tension in both the strings must be equal. So drawing this point over here, we will have something like T2 cos 45, T2 cos 45 to T2 sin 45 is equals to downward is T1, and this T1 will be equal to mg, so I am writing directly equals to mg, small mg. Okay, at this point this angle will also be 45. Now drawing this point on the next page, we will have capital mg, this will be T2, and this will be T3, and the angle will be theta with horizontal, and this will be 45. So we can write this direction, we have force mg plus T2 cos 45, this direction we will have T2 sin 45, in this direction we will have T3 sin theta, this direction we will have T3 cos theta. So T2 sin 45 equals to T3 cos theta, and mg plus T2 cos 45 equals to T3 sin theta. Taking the ratio T3 sin theta by T3 cos theta means this is equation number 1, this is equation number 2. We are doing 2 divide with 1. So on the right hand side we will have, on the left hand side we will have mg plus T2 cos 45 upon T2 sin 45 equals to T3 sin upon T3 cos, which is tan theta. So here we get tan theta, and from here we can write 2 T2 1 upon root 2 equals to mg. So 2 and 2 will go, so root 2 T2 is equals to mg. So instead of T2 we will write mg upon root 2. What we will write? Mg upon root 2. So here we have equation mg plus small mg upon root 2, small mg upon root 2. This is capital M, this is capital M. So this M will capital, this M will be capital. So let me correct this first of all. Mg plus mg upon root 2, 1 upon root 2 upon mg root 2, 1 upon root 2 equals to tan theta. Solving both the equation we will get capital M upon small m for this first term. Root 2 and root 2 will go, g and g will go, plus 1 equals to tan theta. And let me make it more clear. We have mg upon root 2. We are having again the problem. This is mg upon root 2 and this is mg upon root 2. So the denominator of denominator will go in the numerator. So we will have 2m by m plus 1 equals to tan theta. Solve it over again. You will get the answer 2m by m plus 1 equals to tan theta, and we have option 2m by m plus 1 tan theta, this one. Okay. Next question is flexible chain of weight W hangs between 2 points A and B which are at the same horizontal level. This is point A and this is point B, which are at the same horizontal level. The inclination of the chain with the horizontal in both the points of support is, this is theta, this is theta. And what is the tension in the chain at midpoint? What is the tension over here? We don't know. Let us see first of all. Here we will have tension. This will be T cos theta and this will be T sin theta. This will be T cos theta and this will be T sin theta. And if we take a close look, we will have a same force. This force is applied on the wall. So by the same force the chain will be pulled. So the chain will have T cos theta in this direction and this T sin theta in this direction, T sin theta, and this is T cos theta. And if we can see, the one more force is acting on the chain, that is mg. So we can write T sin theta 2 times equals to mg. So T is equals to mg upon 2 sin theta. If we come at the lowermost part, this part of chain is pulling this part by T cos theta and this part of chain is pulling this part by T cos theta. So at the midpoint the tension is T cos theta in reality. So T cos theta is tension and T is what? Mg upon 2 cos theta. Mg upon 2, not cos theta, what is that? Sin theta. Mg upon 2 sin theta into cos theta equals to tension. So that is mg is w by 2, cos by sin is cot theta equals to tension. This is our answer, W by 2 cot theta. Here we have adjoining figure shows the force of 40 Newton acting on the 30 degree inclination. 40 Newton, 30 degree with horizontal, and 5 kg is resting on the smooth horizontal surface, assuming that the acceleration of free fall g is 10. Which of the following statements A, B, C, D are correct? The horizontal force acting on the body is this is the horizontal force, that is 40 cos 30, and cos 30 is root 3 by 2, that is 20 root 3. So this 20 is wrong. The weight of the 5 kg mass acts vertically downward. The weight force will definitely act downward, and that is of 50 Newton. So this is correct. The net vertical force acting on the body, the net vertical force acting on the body is 30 Newton. See, this is 20 root 3, and this is 20 Newton. 50 Newton will act downward, and 30 Newton of normal. This is normal. This is external, applied by us, external, and this is weight. So net vertical force acting on the body is not 30 Newton, but that is 0 Newton. So we have answer is only option 2. Option 2 is only correct option. So this much is enough for today. The end. Thanks for watching. See you in the next class.